So today we're going to talk about how to use the properties that we learned yesterday, how to use multiple of them at the same time, because a lot of times the expressions that we're dealing with are going to have more than just two things going on. So we got to know how to use them all together. So how to simplify expressions using multiple properties of exponents. The first thing you want to do is make sure every number in every term has an exponent. Remember, if one isn't written, it's an implied one. What?
Is this new?
Yeah.
Amelia's the only reason I came to school today.
Every variable and every number has an exponent. I didn't like it. And remember, if one isn't written, it's 1. Okay, so just doing this first will help you stay organized and just remember that even though an exponent isn't written, there is still one there, and it's a 1. And then you are going to start from the inside and work your way out, similar to like how we use the order of operations. Work your way out using one property at a time. Okay, as we do more and more of these problems, you might be able to do multiple properties at once, do some things in your head, and that's okay. But as we get started, it's going to be very helpful for you to just do one thing at a time. Don't try to do it all at once. And then showing all your work then will make it easier for me to give you partial credit. So, good thing to practice. Okay, so once you do your simplifying and you think you're done, how to know if you have simplified completely is that first there are no negative exponents left. So remember, to get rid of the negative exponents, you just move those terms either from the numerator to the denominator or denominator to numerator. And then there also needs to only be one term for each base. Meaning you can't have like a multiple x term still hanging out. You should be able to use the properties that we learned yesterday to get it condensed down to one term per base. So like one x term with an exponent, one y term with an exponent, just depending on the expression. Okay, so example 1a. We want to simplify the following completely. Then we're going to leave an exponential form. This just means if we're dealing with numbers as our bases, we can leave it as like 2 to the 6th, so we can leave that number with an exponent. We don't have to plug that in the calculator and get that value. So example 1a, first thing we want to do is make sure every single variable has an exponent. So our numerator has an exponent, which is good, but our denominator doesn't have one. What's the exponent of that x? What? Of this guy right here? It's 1. Okay, so now we are going to start from the inside. So we're going to start just inside those parentheses and use one property at a time. So inside we have these two terms being divided, which means we can use the quotient rule. Yes, which means we will subtract the exponents. So we'll have x to the 3 minus 1, still all to the negative 3rd power. So we're not dealing with this negative 3 yet, but I'm going to keep writing it so I don't forget that it's there. And then 3 minus 1 will give us x squared to the negative 3. Okay, and now what could I do to simplify this? Not yet. I would do this first. If you want to do it over, do 1 over, and then do the multiplying, that's okay. But this will just make it a little more clear as to what needs to move when you do the negative exponent. So if we multiply these first using the power rule, x2 times negative 3, this will give us x to the negative 6. And then what do negative exponents mean we have to do? Yeah, put it on the bottom. So this would become 1 over x to the positive 6, because once you move it, the negative goes away. Its job is done. Okay, so it's just putting all these properties together and using multiple of them. Okay. Letter B. So we have all our bases are 2's, which is good. That means we'll be able to simplify all of them. And they all have exponents right now, so that's good. Now we can start from the inside and work our way out. In this case, when we just have a big fraction, the inside will be deal with the numerator first, get that as simplified as possible, and deal with the denominator first, get that as simplified as possible, and then work on combining the numerator and denominator. So in our numerator, these two terms are being multiplied, so what will I do to the exponent? I heard a whisper. You will add. This is the product rule. Yeah?
Those 2 3, those cancel out.
No, because one is negative and one is positive. So in our numerator, we can have 2 to the 4 plus negative 3, which will give us 2 to the first. Okay, then we can look at our denominator, use our product rule as there as well. So we'd add our exponents, 2 to the 2 plus 3, which will give us, 2 to the 5th. Okay, now I'm down to one term in the numerator, one term in the denominator. What will I do to these exponents?
4.
What will I do to these exponents? Subtract. You're using the quotient rule. So we'd have 2 to the 1 minus 5. Remember, it's always top minus bottom. Order is very important when you're dealing with the quotient rule. Remember, with division, you subtract the exponents. This will be 2 to the negative 4th. And the negative exponents, what do I have to do? Put it on the bottom. So 1 over 2 to the positive 4. Because once you move it, negative goes away. Okay. Can you guys try letter C? So remember, first things first, make sure every single variable has an exponent. So you'll want to put that 1 in the denominator there, y to the first. Start with the numerator, combine those, then deal with the fraction, then deal with the exponent on the outside. So go ahead, take a minute, try letter C. Everybody try letter C. Okay, so with letter C, you should have dealt with the numerator first. So y to the negative 2 times y to the 4th. So this is using the product rule. So we'd still have this to the 3rd power on the outside. We still have the y to the 1st in the denominator because we didn't do anything with that. We were just focused on the numerator. So this would be y to the negative 2 plus 4, which would give us y to the 2nd. And then we can deal with this division using our quotient rule. So we subtract the exponents. So y to the 2 minus 1 power would give us y to the 1st, still raised to the 3rd. Then we can use our power rule, where we multiply. So we'll have y to the 1 times 3, or y to the 3rd. Okay, do you guys have any questions on this?
42.
Okay. All right. So example 2. Again, we're leaving in exponential form, so we don't have to evaluate any exponents. So when we have a 0 as an exponent, there's 2 ways to deal with it. First, we know yesterday we learned that anything to the 0 power equals what? 1. So that means this whole term, 2 to the 0 power, is 1 times 2 to the negative 4th. So you could just rewrite it as 1 times 2 to the negative 4th. To the 4th, or you don't even have to write that 1, because 1 times anything is just itself. Or if you want to just keep that 2 to the 0 there and use the product rule where you add the exponents, you would end up doing 0 plus -4. 0 plus -4 is still -4. So either way, you'd end up with the same answer. It just depends on what makes the most sense to you. If you want to just get rid of anything to the 0 exponent, or if you want to do the addition, do the product rule. That works too. Okay, so this, now we have a power raised to a power, so we can use our power rule. What do I do to the exponents? Multiply, so -4 times 4. 2 to the -16. But am I done? Nope, what do I have to do? Yeah, 1 over, because it's a negative exponent. All right. Letter B. I want to make sure every variable has an exponent. So this first x here, I'm going to put that 1 in the exponent, just so I remember that it has an exponent of 1. Then I'm going to start with my numerator and use my product rule to combine these two. So we'll have 1 plus 2, so x to the third, over x to the 7th raised to the third. Then I can use, they're being divided, so I can use the quotient rule. So we'll have x to the 3 minus 7, which gives us -4. And then we just have one term with 2 exponents, so we can use our power rule. So this would be x to the -12th, but that negative exponent means we have to move it. So 1 over x to the 12th. Okay, can you guys try letter C? So letter C, all the y's already have exponents, so that's good. So I would just start in the numerator, get that as simplified as you can, get the denominator as simplified as you can, and then use your quotient rule after that. Okay, so again with this one, we have a y to the 0 power here, so if you want to just ignore it, that's fine. Because it's really just a 1. 1 times anything is just going to be itself. So it's up to you how you want to deal with that. So then in our numerator, we can use our product rule. We can use our product rule in the denominator. So 7 plus a -2 and 3 plus a -6. This will give us y to the 5th and y to the -3. Okay, then we can use the quotient rule. This is where you have to be careful. When you have negatives in the denominator, you still have to subtract no matter what. Even if some of the exponents are already negative, cool, good for them, you still have to subtract. Gentlemen. You still have to subtract when you are using the quotient rule. So this would be y to the 5 minus a -3. And you subtract a negative, what's that the same as doing? Adding. So really this is going to be y to the +8. Just got to be careful with that. All right, do you guys have any questions?